All right, what's up, guys? I wanted to start with a quick review of kind of what we've been doing with a fully factored out polynomial. What's the different things that we could say about it? Okay. Now, all right. The first thing it's asking me for is the degree. You guys, that basically means how many x's. It means like if I were to multiply out this whole thing, okay? I definitely don't want to do that. That would be horrible. But if I were, what would my first term be? Well, I have an x from there. This one I have an x squared, right? This one I have an x, and this one I have an x to the third. So how many x's do I have? 1, 2, 3, 4, 5, 6, 7. So this is an x to the 7th, and it's positive. Okay, so the degree is 7. All right. We'll come back and do the end behavior in just a second. Okay, these are the things that are known as factors. X plus 5 is a factor. X plus 1 is a factor. It's okay if you put the squared on there, but you don't have to. It just means it has two of those factors. X minus 2 is a factor, and x minus 3 is a factor. Okay, now that means that the solutions are x equals negative 5, x equals negative 1, x equals 2, and x equals 3. Because we're basically setting each of those equal to 0 and solving it. All right, and so it like switches the signs, right? Now, it also says to state the multiplicity of each 0. That basically means how many times does that factor occur in the equation. So if I look at x plus 5, that's only one time. But x plus 1 is twice. So this solution has a multiplicity of 2. You can either write it twice or you can just say it has a multiplicity of 2. Okay, that one just happens once, that's fine. And then that one happens 3 times. That has a multiplicity of 3. I mean, you can also just you could write it like this. You could be like, okay, negative 5, and then I have 2 negative 1s, and then I have a negative 2, and then I have 3 of these. Those are my solutions. Now, a bunch of them are repeating, but how many do I have? 1, 2, 3, 4, 5, 6, 7, 7. Okay? So I have a perfect number of solutions that I'm supposed to have. All right, so now let's go down to this next one. The Y-intercept. Okay, you guys. The Y-intercept, let me come back to the beginning question here, is just when I plug in 0 for x, what do I get? Okay? I think this is going to be a crazy number. We'll see. If I didn't even make the graph big enough. 5. If I plug in 0 right here, I get 1 squared, which is 1. If I plug in 0 right here, I get negative 2. And if I plug in 0 right here, I get negative 3 to the third. Now, negative 3 to the third is negative 27. Okay, so this Y-intercept is going to be awesome. 5 times 1 times negative 2 times negative 27. Cool. My Y-intercept is 270. So like I'm feeling like on my graph, you know, we should do, since it goes all the way up to 270, we should go by 100s. So that'll be 100, 200, 300, just on the y-axis. Negative 100, 200, 300. You know, it doesn't really, I'm really mostly looking for what's happening on the x-axis, but I'm going to go and just put those in terms of hundreds on the y-axis, okay? Let me write that a little bit better. So that's going to be, instead of 3, we'll make that 300, 200, 100. Okay, so we'll go by 100s to accommodate for that y-intercept. That's crazy. Okay, end behavior is the arrows, right? So we've talked about this. My arrows for this, okay, I have an odd degree, and it's positive. Odd positive, we know, goes down, up. All right, so my arrows are down, up. Okay, and now we're going to sketch it with all that information. So the first thing I do is I put my solutions. Let's see, negative 5, negative 1, 2, and 3. And I'm also going to remind myself of what happens at each one. Now, at negative 5, it just crosses like normal. But at negative 1, it's going to bounce right here. All right, so I'm just going to put a little B to remind myself when I'm drawing it. At 2, it's going to cross like normal, but at 3, it's going to, see, I call this a flat cross. I don't know what else to call it, but it kind of looks like that. It crosses, but it flattens out. It doesn't completely go flat. It just kind of flattens out and then goes, and then keeps going. So I call that like a flat cross, all right? Those are all my zeros and what happens at each one. The Y-intercept we said was 270. So this is going by 1, 2, 3, 4. 1, 2, 3. Okay, so this is going by like 25, 50, 70. So 270 would be like right there. I'm just estimating, okay? And then my arrows go from down to up. All right, so now this is the cool part. This is where we're going to draw it all in, okay? So I'm going to connect these arrows by crossing, bouncing. Do I know how high it goes? No, I do not. Crossing, flat cross. I didn't exactly hit that one, so that's okay. There we go. All right, and there's like a pretty decent picture of what that crazy polynomial would look like, okay? Now, you guys, sometimes we have weird solutions. Today, we're going to kind of talk about weird solutions, all right? Okay, check it. These are all factors. Okay, these are all factors of a polynomial. Here's what the solutions are. Okay, so for this one, if I let x plus 3 equal to 0 and I solved it, I would get negative 3. This one, if I let 2x minus 1 equal to 0 and I solved it, I would add 1, divide by 2, so x equals a half. Okay? That's how I would do those. My next two, if I were to solve that, x would be negative square root 2, positive square root 2. Okay? And then here, if I solve these, so I put that in parentheses because it's x minus. So one of my solutions would be 4 plus 5i, and the other solution would be 4 minus 5i. We've talked before about how imaginary solutions come in pairs. So I'm going to get two of them together, okay? Okay, so it says now list what type of solution each one is. Okay, you guys, so here's where this is kind of fun. These first ones, these two, these are rational. Okay, rational is a number that can be made into a fraction. It's also a number that I could put on the graph. I can actually like graph it pretty easily. Okay, the next type I have are irrational. This means if I were to put those in my calculator, right, I would get an answer. I would get a decimal, but it would be like, yeah, it'd be all decimally and crazy. I can graph those. So let's put like, I can, wait, let me do something real quick. Okay. I can graph rational and I can graph irrational. So like I could see them on the graph. I just need a decimal. I need a calculator to do those, right? Okay, these last ones are called, we've done these before already, but these are called imaginary. All right, and the thing about those is you actually cannot see them on a graph. They are just not going to show up on your graph. So it's kind of, you got to do some extra stuff to find them because you can't just look at the graph and tell. Okay? But we're going to learn a really cool theorem today. And it's called the rational zero theorem. Now, that looks crazy, right? Look at all this, what it's talking about. This looks insane. Okay, what this saying is if I have any polynomial, okay, any polynomial. So don't think of it with like a sub n, x to the n, a sub n minus 1, x to n minus 1. Just think about it as like a polynomial. Like that's a polynomial, that's a polynomial. Okay, so any polynomial. If it's going to have any rational numbers, it has to be of the form p over q, where p is a factor of the constant term at the end. Q is a factor of the leading coefficient. Okay, I don't really know why they use P and Q. I don't know, there's an old saying once, mind your P's and Q's. I don't know. Who knows where we get this from. Okay? All right, so this is how it works. Let me show you guys. So first of all, I'm going to list all of the factors of P. Actually, I won't. I'll put plus or minus on at the end. Hold on. Okay, I'm going to list all the factors of P. This is P right here, the number 4. Factors means what it divides by. 4 divides by 1. 4 divides by 2. It doesn't divide by 3, and it divides by 4. Okay, so those are my P values, and those are all like plus or minus. My Q values are this number right here. Now, if there's a negative, go ahead and ignore it because it's plus minus anyway. So it's just 1. The only factor of 1 is 1. That's it. So when I do P over Q, here's what I get. Okay, and I kind of go like this. All right. 1 divided by 1, 1. 2 divided by 1 is 2. And 4 divided by 1 is 4. Now, does that mean that those have to be solutions? Definitely not. Those are just possible solutions. What it's saying is that if I have a rational number, so not counting irrationals, not counting imaginaries, if I have a number answer to this, it has to be either, I just put the plus minus at the beginning, but positive 1, negative 1, positive 2, negative 2, positive 4, negative 4. Those are the only choices. So if I were to then solve this and I got an answer of 7, it's wrong because it's not off that list, okay? It has to be off that list to be a possibility. So it could only be positive or negative 1, 2, or 4. All right. Gets a little bit trickier with this one. Let's see how it goes. Okay. My P is 3, and the factors of 3 are 1 and 3. That's all goes into it. My Q is 15. The factors of that are 1. 2 doesn't go into 15, but 3 does. 4 does not. 5 does. 6, 7, 8, 9, 10. None of those go into 15 until 15. Okay. Now, I've got kind of a lot of choices here. So here's what I'm going to do. I'm going to divide both of these by 1. 1 divided by 1 is 1. 3 divided by 1 is 3. So that took care of that. Okay. Now, I'm going to divide both of these numbers by 3. That gives me 1 over 3 and 3 over 3. You might be noticing something, and that's fine. I'm going to come back and fix it. You're staring at your screen like, oh, Ms. Mitchell. Okay, I got you. All right? Now I'm going to divide them both by 5. That's going to be 1 over 5, 3 over 5. All right? And then my last one I'm going to divide by 15. That's going to be 1 over 15 and 3 over 15. Now, when you guys write these down, you are going to want to reduce them. And the ones that I can reduce are basically right here. 3 over 3, which is 1, and then 3 over 15, which is 1/5. Well, 1 is already represented, so I don't need that. 1/5 is already represented. It's right there, so I don't need that. Okay, so my final choices are 1/3, 1/3, 1/5, 3/5, and 1/15. And each of them are plus minus. Even though right at the beginning, every single one is plus minus. So there's 6 numbers. If they're all plus minus, there's 12 total numbers that it could possibly be. Okay? We could look at the graph, we could figure it out and see what numbers actually work, but those are my possibilities. All right? So the type of questions that we're going to do is I'm going to give you guys an equation. It's not factored, and we don't even know how to factor it. All right? We don't know how to factor this. Okay, so it can't factor, so how are we supposed to decide what it goes into? Well, first we come over here, we list our P's over Q's. My P's are 6, which is 1, 2, 3, 6. My Q's are 1. And so if I divide all those by 1, 1 divided by 1, 2 divided by 1, 3 divided by 1, 6 divided by 1. So those are my choices, okay? Okay, so now at this point, I'm going to go through and I'm going to test every single one of those numbers until I find one that works. All right. Now here's my hint to you. It's usually the smaller numbers. I would say like more than 50% of the time, either 1 or -1 works, you know? So excuse me. So start over here. Try +1, then try -1. +2, -2, +3, -3. And just keep going until you find the one that works, okay? We're going to do synthetic division. So I'm going to start with +1. Okay, and remember we learned with synthetic division, we put our numbers here. We go like this. I bring down the 1. 1 times 1 is 1. That's 3. 3 times 1 is 3. That's -2. -2 times 1 is -2. That's -8. Because I got a remainder right here, that means that this is not a solution. So I'm going to come up here and say, nope, that is not a solution. Now I'm going to try my next number. I'm going to try -1. I mean, you try whatever you want, like go in whatever order. That's usually the order I go in. 1 times -1 is -1. 2 minus 1 is 1. 1 times -1 is -1. That's -6. -6 times -1 is +6. That's 0. That's good. As soon as I see that my remainder is 0, I have now found my first solution. Okay? So x equals -1 is my first solution. All right? Now I need to go through and find my other solutions. I could keep on going with like testing these over and over again, but there's actually a faster way. Okay, guys? This was originally an x to the third. When I find something that works, this is now an x squared. And so I have this equation. X squared plus x minus 6. And I need to solve that equation right there. Okay? Well, I can solve this by factoring. If we can factor, that's what we want to do, because otherwise we're going to have to do quadratic or something. I can solve this by factoring. All right? When I do factoring on here, I'm going to get... Oh, let me put my x over here, actually. Okay, so -6, +1. 3 times 2 plus minus. Okay? So it's x plus 3, x minus 2 equals 0. So my solutions are -3 and +2. So guess what? Those are my other two solutions. And it was a third degree polynomial, so I need to have 3 solutions. Okay? Now, what type of solution is each one of these? These are all rational solutions. Basically like fractions or whole numbers or whatever, those are all rational numbers. And notice, if it's a rational number, it has to be off of this list. Okay, -1, yeah, that's on the list. -3, that's on the list. 2, that's on the list. Everything's on the list. So we're cool. All right, those were all 3 rational zeros. Okay? All right, nice. Let's go ahead and look at this next one. Ooh, this is going to have a lot of choices. Don't worry about the negative for now. My factors of p is 20. 1 goes into 20, 2 goes into 20, 4 goes into 20, 5 goes into 20, 10 goes into 20, and 20 goes into 20. That's a lot of numbers. Okay, luckily for my q, it's just 1. And when I divide each of these by 1, okay, so it's basically plus or minus 1, 2, 4, 5, 10, and 20. So that's a lot of choices, okay? That's a lot of choices. But I'm just gonna plow through here. I'm gonna start with 1 and see if this works. 1 times 1 is 1, that's 9. 9 times 1 is 9, that's 20. 20 times 1 is 20, that's 0. I really love it when I get lucky on the first try. So, you know, I put all these different boxes here just in case we needed to do a bunch, but I found it on my first try, so I'm good. So my first solution is 1. Okay? Nice. Okay, so now I'm going to take this and make an equation out of it. Okay, this was x to the third. So when I come down here, this is now x squared with no remainder, right? So it's x squared plus 9x plus 20. And again, if I can factor this by factoring, I should. All right. What multiplies to make 20 and adds to make 9 is going to be 5 and 4. Okay. So this factors to x plus 5, x plus 4, and my solutions are negative 5, negative 4. So there's all three solutions. Notice, again, these are all rational solutions. Now, what that means is if I had started my synthetic division with negative 4, that would have worked. So if I didn't test 1, negative 1, 2, negative 2, 4, negative 4 would have worked. 5, negative 5 would have worked. Those are the numbers that would work on synthetic division. But you only have to find 1 because then you can factor for the rest. Okay? All right, awesome. Let's check this one out. This is going to be plus or minus 1 and 3 over plus or minus 1. So it's basically just plus or minus 1, plus or minus 3. Okay, so I'm going to go ahead and start doing some synthetic division. Okay, 1 times 1 is 1, and that's 8. 8 times 1 is 8, and that's 19. 19 times 1 is 19. I can already tell it's not going to work. You don't even have to necessarily finish it, but I know that that is not a solution. Okay, so now I'm going to try negative 1. One times negative 1 is negative 1, that's 6. 6 times negative 1 is negative 6, that's 5. 5 times negative 1 is negative 5, that's negative 8. Also, not a solution. So we got to keep going. Okay, so now I'll take 3. 1 times 3 is 3, that's 10. 3 times 10 is 30, that's 41. Can you already tell this is not going to work out, you guys? I can tell it's not going to work out. 41 times 3 is 123, so it has a remainder of 120. Bad luck. So I'm really hoping that negative 3 works because, I mean, if it doesn't, there's really no way to solve this because I've already gone through all of my possibilities, Okay, 1 times negative 3 is negative 3. That's 4. 4 times negative 3 is negative 12. When I subtract that, I get negative 1. Negative 1 times negative 3 is 3. Remainder of 0. Okay, so awesome. I got my first solution. Okay, so now I'm going to take this and write an equation out of it. All right. So I'm going to try to factor this equation. Now, when I say what multiplies to make negative 1 and adds to make 4, guess what? Nothing can do that. I mean, 1 times 1 is the only thing that makes negative 1, right? So it's not factorable. And guys, what are we going to do if it's not factorable? We're going to cry, right? No, we are not going to cry, my friends. We are going to persevere. All right? If it's not factorable, we have to do the quadratic formula. It's just the only way to do it. Okay? So, quadratic formula goes like this. Negative b plus or minus the square root of b squared minus 4ac all over 2a. Okay? And just like we had practiced doing quadratics before, we got to simplify this. Okay, now in the square root, you guys, I have 4 squared, that's 16, minus a negative is plus, 4 times 1 times 1 is 4. So 16 plus 4 in the square root sign, that's going to give me 20. And then you guys remember how we talked about how you can break this down. So we want to simplify the square root. 20 is 4 times 5. 4 is 2 times 2, so I have a pair of 2's. So I end up getting negative 4 plus or minus 2 comes out of the square root. 5 stays in, and I have a 2 on the bottom. My last step, this is a kind of crazy long one, is, okay, I can divide each of those by 2 to get that. All right, so my solutions are, let's see, negative 2 plus or minus 1 square root 5. Guys, that counts for 2 solutions. Now, you don't have to list them out separately. Okay, one solution is that. one solution is that. One's plus, one's minus. But you do not have to list them out separately, okay? Okay, so I've got my 3 solutions, and here we go. Now, what types of solutions are these? Okay, well, they're different. This one is rational. Okay, the -3 is rational. These right here are irrational. Irrational means it basically has a square root in it. You need your calculator to, figure out where it's going to be on the graph, but you could still graph it. I can put that on my calculator and get a decimal value, okay? All right, nice. Let's look at a couple more difficult ones. Because you guys, now I'm going up to x to the 4th. What that tells me is that I have to actually do synthetic division twice to get down to something that I can factor, okay? Check it out. Okay, the factors of 24 are 1, 2, 3, 4, 6, 8, 12, and 24. The factors of 1 are 1. So it's just 1, 2, 3, 4, 6, 8, 12, and 24. The positive and negative of each of those. Guys, that's a lot of numbers, okay? Now, if I tell you, okay, you can use a calculator or a graphing utility to kind of help you figure out where to start. Okay, only if I tell you. I'm going to tell you some, I want you to do it completely by hand. Some I'll say, all right, you can use a graphing calculator if you want. Okay, so here's what you do. Okay, so I'm going to go over to, you can use a graphing calculator. You can also just type it in on Desmos, which is what I did. I'm going to go over here, and you can see a solution on there. If it's Desmos, you can just type the screen on the calculator. You can kind of look and see. There's a solution at 2, right? So I have a solution on here. That's good. And so you know what this tells me, you guys? This tells me what number I should start with. This tells me that 1 is not going to work because there's no number 1 on the graph. It tells me -1 is not going to work, but 2 is going to work, okay? So it kind of helps you find that first number so you're not doing synthetic division for days, all right? So if I tell you that you can do that, then that's fine. You can do that. If I want you to actually test them, then you need to test them. Okay. Here's the other thing that's a little bit tricky on this. Right here. See how it's 4, 2, 1, 0? Well, that's not this polynomial's full name. Actually, its full name is x to the 4th plus 0x to the 3rd minus 6x squared minus 8x plus 24. We talked about how you have to put a 0 in if it's missing any terms when you're doing synthetic division, okay? Okay, so I'm going to go like this. If I bring down 1, 1 times 2 is 2, that's 2. 2 times 2 is 4, that's -2. -2 times 2 is -4, that's -12. And -12 times 2 is -24, which is 0, which is great. It means I have no remainder, which means 2 is definitely a solution. Now I need to go find another one, all right? I need to go find another solution because it started off as x to the 4. So that just came down to x to the 3rd, but I can't factor in x to the 3rd. I need to go down to x squared, and then I can either factor or do quadratic. So I got to do synthetic again, okay? Now look, I already took off 1. I already took off -1. They didn't work. Let's say I had tried this over here. Say I had tried 1 and I had tried -1, okay? Doesn't work, doesn't work. But I tried 2. I actually want to try it again. Okay, I want to try it again to see if maybe it's a double or something. So I'm going to go ahead and do 2 one more time, but this time with these numbers right here. So it already divided by 2 once. Let's see if it can divide by 2 again. And if not, I'll move on to -2 or 3, -3, whatever. Okay. I'm actually going to use this box over here because it gives me a little bit more room. So now I'm using those numbers, okay? 1 times 2 is 2, that's 4. 4 times 2 is 8, that's 6. 6 times 2 is 12, that's 0, right? So that's great. 2 worked a second time. You guys, that means it's a double solution. So on my list, I'm either going to put 2 and 2. I'm going to write it twice. Or I can put 2 and it has a multiplicity of 2. To show me, I'll put it like down here, that actually counts for 2 of my solutions, okay? Not just 1, that counts for 2 of my solutions. Now, I'm going to take this part that's left right here and see if I can solve it. So this first one was x to the 4th, this one was x to the 3rd, so now this one is x squared. Okay, so let's write it like this. X squared plus 4x plus 6 equals 0. All right. Okay, so, first I would try factoring, because we always want to at least try factoring first. I already know it's not going to work, and I'll tell you in a minute why I know it's not going to work, but, okay. As I look at this, what multiplies to make 6? So like 6 times 1, 2 times 3. Nothing adds to make 4. So you guys, this is not factorable. All right? Factoring is not going to work for me. Okay? So what do I have to do if factoring doesn't work? I got to do the quadratic formula. So I got negative b plus or minus b squared minus 4ac all over 2a. Now inside of this square root sign, 4 squared is 16. 4 times 1 times 6 is 24. So I get negative 8. All right? Now I already knew that I wasn't going to be able to see the solutions. See, I knew they were going to be imaginary. You know why? Because on my graph, there's no other solutions here. And I actually knew 2 was going to be a double. How did I know 2 was going to be a double? Because look, it bounces. So just from looking at that, you could tell 2 is going to be a double and there's no other solution. So I knew it was going to be imaginary, right? Okay. So now let's simplify this. So what I'm going to do is I'm going to take that negative out. I'm going to make that I. Okay, I'm going to break down 8. That's 2 times 4, 2 times 2. So that's 2 rad 2. 2 on the outside, 2 on the inside. All over 2. I check my 3 spots to see if this can reduce at all. 2 goes into 4 2 times, 1 time, and 1 time. So here's my final other 2 answers for this. Negative 2 plus or minus I square root 2. Okay, I have 4 answers now, you guys. It was an x to the 4th. I have to have 4. 2, 2, and then the plus or minus I, right? So it's a total of 4. What type of solution is each 0? Well, look, I have some rational solutions right here. And I have imaginary solutions. All right, so those are the different types. So I have 2 rational, 2 imaginary. I have 4 total solutions. Okay? All right, cool. Last one. Okay, let me go ahead and make my list. Okay, so factors of 6 are 1, 2, 3, 6. Factors of 4 are 1, 2, 4. This list is going to be a little bit of a pain here because, okay, let's see. If I divide everything by 1, right, that's just 1, 2, 3, 6. If I divide everything by 2, that's 1 over 2. That's 2 over 2. But I don't have to list that again because 2 over 2 is 1. I already got it, so I'm fine. That's 3 over 2. And that's 6 over 2, which is 3. And I've already got that, so I'm not going to list that again either. Now I'm going to do the over 4s, okay? All right, cool. So I'm going to do it over 4. So that's 1 over 4. Guess what? I'm not going to put 2 over 4 because 2 over 4 is a half. I already listed it. 3 over 4 I have not listed yet. And then 6 over 4. Well, 6 over 4 is 3 halves, which I already have listed. Now this is a lot of numbers that I would have to try. okay? So you'd go through, you'd test 1, -1, 2, -2, 3, -3, okay? But I'm actually going to go ahead and put this in decimals and try to see from here. Okay, so I went ahead and graphed this. Now you guys can see that one of my zeros is at 1. So I'm going to try 1 and it's going to work. But now I got to try another number, and it looks like it's not crossing like perfectly, but let's see. Okay, do you guys know what decimal that is? -0.75. 75 is 3/4. So I already know the ones that are going to work are, okay, so I did a little like cheating. I kind of looked it up a little bit. It's not really cheating. You know what I mean. 1 is going to work and -3/4 is going to work. So let's start with 1. I'm going to put all my coefficients here. 4 times 1 is 4, that's 3. 3 times 1 is 3, that's 8. 8 times 1 is 8, that's 6. 6 times 1 is 6, that's 0. All right? So 1 is a solution because I got 0 right here. So I can go ahead and put 1 on my list. Okay, then I'm going to use these numbers right here and do synthetic division again. Now, it looks like it's going to be really horrible because of the -3/4. I promise you it's not that bad, okay? It's a little bad. It's not that bad. 4 times 3/4, or 4 times -3/4. Well, the 4's cancel out, so I just get -3. And 3 minus 3 is 0. Okay? 0 times 3/4 is 0. So that gives me 8. Now, 8 times -3/4. 8 times -3/4. 4 goes into 8 2 times. That gives me -6. And then guess what? 6 minus 6 is 0. So, awesome. I got 0. And it tells me that this works. Now, I wasn't necessarily just checking to see if those worked. I mean, I'm pretty confident that my calculator told me across those points. But what I really was looking for was this little part right here. So that original one was x to the 4th. The next one down is x to the 3rd. So this one is x squared. 4x squared plus 0x plus 8. Okay? Well, the 0x I don't have to write. I'm going to write 4x squared plus 8. Now, guys, you could do a quadratic formula on this. I'm not going to. Let me show you how I'm going to solve it. If I'm missing the middle term, okay, look what I can do. I subtract the 8 over. I get 4x squared is -8. Okay, divide both sides by 4. I get x squared is -2. And then square root both sides. Okay, first of all, when I square both sides, it's plus or minus. All right, plus or minus. The square root of 2 cannot break down, but I took the negative out. Well, I can take the negative out. That's going to be an I, and then there's a square root of 2 left over. So those are my last two solutions. So it's plus or minus I square root 2. So I can solve it that way. Okay, these are rational. These are imaginary because they have the I in them. All right? So hopefully that makes sense, and we'll try a few of these for homework tonight.